Hey and welcome. Today is the 23rd of September 2025, and my name is Florian Moberg, also known as Gyptasy. Today I want to introduce you to ProxLB. ProxLB is short for Prox Load Balancer, which is a load balancer for Proxmox related systems. And what is ProxLB? So ProxLB is something like equivalent to DRS in VMware. It makes sure that we can rebalance our guest objects of type VM, virtual machines, or of containers, like C-based ones, within the nodes and the cluster and Proxmox. And this means we need to evaluate the things behind it. In that case, we are going to evaluate the resources we have in general on the Proxmox nodes, how they are being utilized, and we do the same for the VM-based objects, but also for the LXC containers. So we are going to evaluate the CPU usage, the disk usage, and the memory usage. And this provides us the possibility to gather the metrics and to make calculations for best placement for VMs in a Proxmox cluster. So this project has been founded in 2024 by me. I am currently the lead developer behind the project, and it has been inspired by my BoxyBSD project. In my BoxyBSD project, I provide free VPS instances for educational purposes to individuals, which means they can simply sign up and create a new BSD-based VM anywhere around the globe. But this often led into issues where nodes has been over-provisioned. And this made me create ProxLB to make sure that I have the nodes equally balanced, and to make sure that we do not end up with over-provisioned nodes, we had to create a new solution. And yeah, afterwards I found out that we do not have any such solutions, so I had to create one myself. And as a result, I created ProxLB project, which is fully free and open source and licensed under the GPL v3 license. The current key features has been improved over all the releases. So it started just by having something like intelligent workload distribution. So it made sure that we can balance guest objects by memory, CPU, and local disk resource consumption over the cluster nodes. And afterwards, it gained some new features. One of the most important features is the maintenance mode, because when we're going to apply maintenances, for example, we have security updates which we need to integrate on the node. So we need to drain the node, and to make sure that we can safely reboot it, we can simply add the node in ProxLB in maintenance mode, which makes sure that we can safely drain the node, that where all VM workloads being migrated by the resource consumption over all the nodes in the cluster. But in one of the latest releases, we also gained new features like Affinity and Anti-Affinity rules. So this means that we can create groups of VMs that should be run together on a specified node, or that should be kept apart from each other, which means that the guest objects are running on different nodes, which might make sense if you're running virtualized database clusters or NTP systems or name servers and so on, where you want to make sure that if a node crashes or is absent or anything happens, that the systems are still reachable for HR on layer 7. So these are things that you can achieve with ProxLB, simply setting and defining affinity and anti-affinity rules. One of the key features apart from that is that ProxLB runs fully in API-driven mode. So ProxLB does not need any SSH access to any of the nodes. We are fully utilizing the Proxmox API, including all the ACL system behind it. So the whole authentication and authorization part is taken by Proxmox. And we can simply also define the required roles, which means that we can make sure that we only define the required roles that ProxLB uses for gathering the metrics and to migrate the VM objects without any further access to the nodes. How does ProxLB work on the end? So it's pretty easy. In the first step, we just gather all the metrics of the nodes. So this means we're iterating through the cluster, getting all the nodes that are containing and included in the cluster, and afterwards gathering all the metric information of each node. In the end, we end up with a huge matrix of all nodes with an overview of all CPUs, with CPU usage in percent, the same for memory and for loaded disk usage. Afterwards, we iterate through each VM in each node, which means we end up with a much bigger matrix. This includes the nodes and the VM objects, with all their assigned resources and their used resources. Afterwards, we can simply proceed with the balancing evaluation. During the balancing evaluation, we also need to make sure that we honor the affinity and anti-affinity rules. So there are some corner cases how it's being done, but in the end, it's mostly done by the resource evaluation, in addition to the affinity and anti-affinity rules, but also to some other things like node maintenance, node pinning, where we can pin nodes to a specific node or to a group of nodes, or to simply ignore nodes, but also VMs. So ignoring VMs might be interesting if you have something like PCI pass-through configured, where you have maybe just one node having a dedicated GPU, which is being used inside of VMs. And yeah, there doesn't really make sense to migrate the VM away from that node because it can't really utilize the GPU anymore. So we want to pin it or to ignore it in that case. But another case might be for pinning, where you have maybe some license cases, like let's say you have an Oracle database running in a virtualized environment, and your nodes are maybe more socket ones, but you only have a dedicated node with simply one socket which is licensed for the database, and you want to make sure to run this VM only on this node because you don't want to run in anti-license violations, and then you can simply pin this VM to that specific node or to a group of nodes in case you have multiple ones of them. But this is only one example. There are, of course, also many other ones. And afterwards, the balancing just kicks in and migrates the VMs to the specific nodes based on the calculations. As I initially already said, you also have the possibility to define affinity and anti-affinity rules. And this is one of the most important parts when it comes for enterprise usage, because you often have these requirements to make sure that you can run specific workloads on the same node, which would be affinity rules, or to make sure that you can split your workloads across different nodes in a cluster, which would apply as an anti-affinity rule. So here we already can see an example. If we have Taylor system, it doesn't really make sense here because we also want to split it here. But in that case, we are running a Kubernetes cluster all on the same node. Usually you also want to split it here. It's just to make sure how it looks like. But for a more sane example, we have the anti-affinity rules where we have different NTP systems which are running on different nodes across the cluster. So if node 1 fails, our second NTP server will still run and operate. So this is a good way to achieve something like this without big efforts. And one of the big things here is that it can be done completely from the web UI, from your default Proxmox web interface, by simply defining a tag. And therefore, we just need to define tags starting with PLB underscore affinity underscore some name, how you want to name that group. The same also applies to PLB and underscore anti underscore affinity underscore any group name you want to use for that. And you can also use it for ignore node or for maintenance. And maintenance is one of the huge things. So we can simply define a node that is being set to a maintenance node and will be drained with our workloads. And usually it's a little bit, or in the past it has been a pain to drain a node because we had to do it manually. Some people wrote Ansible scripts, but in that case, it mostly was that the VM workloads has just been migrated to any other node, independently of any resource consumption. And this might lead into over provisioning or problems with the resource consumption on the nodes and so on. So it might make sense to have something like this also automated, where the resources are being evaluated and you can make sure that no over provisioning is going to proceed it. And we have a safe way to move our systems to another node just to perform more maintenance. After migrations, of course, we are good to go. So we can simply shut down the node for hardware maintenances or simply reboot it to take actions for security, applying security updates. Afterwards, when the node is again back and online, we can simply remove it from the maintenance mode, and then all the workloads will be remigrated across all nodes on the cluster based on the best resource calculations. The ProxLB project is fully open source, so it's based on GPL3. You can find everything on GitHub. You can also provide patches and feature implementations there. If you have any questions, always feel free to jump in our Discord or Matrix channel. And in the docs chapter, you can, of course, find all the documentation regarding the configuration, installation, and so on. All right, now let's move over to a quick technical demonstration of how it looks like to install ProxLB and how it can be used. And here we can already see we have a small 3-node size Proxmox cluster running in version 9.9. And yeah, here we can already see that we have 3 nodes attached with not the same memory consumption here, but to be honest, all the nodes do not have so much memory here. So if we have a look at the nodes, we can see that we have overall something like 12 GB of memory. So they are not really huge sized here. And I also already prepared 3 guest objects here. So everyone is running on the first node here. We're going to start it right now. Make sure the systems are later already up and running. And this is usually the cluster I use for developing for Ansible stuff, creating new modules, testing modules, fixing bugs, and so on. And maybe a quick overview about the things behind the Ansible stuff. So you maybe already have noticed some of my new modules, which became upstream very recently in the collections. And this means that you have now the ability to create Proxmox clusters from scratch in a fully automated way. So you can use the Proxmox cluster module to initialize a cluster and to join with other nodes. So this means you can simply create a list of objects with including the nodes and simply use the first slice object, initialize the Proxmox cluster with it, and with the leftovers in the list, you can simply join the cluster. Afterwards, you can use the Proxmox node module from me, so this makes it possible to add and include all the Proxmox-related subscriptions, but also to adjust some other things like certificates and so on, so everything which is in the scope of a node. And afterwards, you can simply use the Proxmox storage module, which means that you are able to integrate some other stuff like Ceph storage, NFS, iSCSI, or even a Proxmox backup server. With all of those things, you are more or less able to create a new cluster in a fully automated way without invoking any mouse movement. And this makes it pretty cool and easy to use and also to spin up new clusters. However, that was a quick introduction about the things. And yeah, so let's move over to ProxLB again. So let me quickly introduce you how we can proceed with ProxLB. And as I already mentioned before, we have different ways how we can install ProxLB. And really, the easiest way would be to use any Debian-based system, because for Debian, we have the repository, which we can simply include to make sure we also get any updates from ProxLB. But there are also predefined packages on the CDN, so you can also grab all the things from the CDN. You can find the CDN packages right here, or simply use the repository. But if you do not intend to use a Debian-based system or to run it on any other system, it even supports FreeBSD, for example. You can simply spin it up anywhere else. It just requires Python, so you're good to go. And if you decide to use any other way, you can also use container images. So there's a Docker image or a general container image, which you can use to run in Docker or Podman. But you can also simply use the newly created Helm chart, which makes it possible to run ProxLB in any Kubernetes cluster. But here also already comes a catch. So many people often ask me, hey, how can I make it possible to run ProxLB in an HR setup? And yeah, the easiest way to achieve this is just create a new HR VM inside your Proxmox cluster. The easiest way would be to spin up a Debian-based HR VM in your cluster, install ProxLB on it, and make sure that it is just shifted to any node failure that it runs on another node. And more or less, that's it. So to give you a small example how these things look like, we are now going to install it on one of the Proxmox nodes. Just make sure if you're going to install it in one of the Proxmox nodes of the cluster, because Proxmox runs a multi-master setup, and also ProxLB would not operate this. This means that if you're going to install it on all nodes in the cluster, you would probably end up in something like a ping pong of migrating the VMs. Why? Because ProxLB already evaluates the calculation based on the resource consumptions of the nodes and VM objects and migrates the VMs. And if multiple ones do this at the same time, they might have a different calculation base, and afterwards you might end up in ongoing infinity rebalances. So simply make sure that it's only running one system or in one administrative VM like HR VM where you're going to operate it, but only on one. And in this case, we are now going to simply install it. So for this case, we are just opening up a console. You can use a web console, or you can also use an SSH connection directly to the node. In this case, we are going to use the repository method. So we can see we already have here a quick start chapter, which we can simply use to copy paste all the commands we need to install it. And with the first two lines, we are just going to add the new repository. So the repository has been added. We can now simply run apt update and install our package. And as we can see, pretty easy. It already also creates a new user for it. And we can simply move over the example configuration and adjust it to our needs. But before we are going to adjust the configuration, we need to create a new user. And when we are talking about creating a new user, we can simply have a quick look. Everything is documented in the project repository. So within the configuration chapter, we can already see that we have the part authentication, user accounts, and permissions. And what we are now going to do is create a new user, because we do not want to run everything under the root account, and we also want to make sure that we are going to create a new dedicated role with just having the roles and permissions that we are required to have to make ProxLB running. And when creating a new role, we create the privileges and roles to the data store audit, sys audit, VM audit, and VM migrate. This means that we can evaluate the data store, only read-only. We can gather all the metrics, how much disk space is being used, how much we have in general, and so on. The same also applies to the Proxmox nodes we have in our cluster, so we can see how many CPUs they have, how much of them are being used, and how much memory. So the same also applies to VM objects. So we can see how much CPU usage and memory consumptions VMs have in general. And yeah, of course, to make sure that we can shift the VMs to other nodes, we have the permissions to migrate the VM objects. All right, so now we are simply going to create a role. Then we are going to create a password for the user, create a new user, and assign a password for it. So it must be at least single digits. We should be good to go with that one. And then we modify the ACL for it. And more or less that's it. At this point, we are already able to use ProxLB with the user and password. But I would really recommend you to avoid using username passwords. Instead, we can simply use token-based authentication. Therefore, we simply create a new token for the user. So this is our token ID, and this is our secret. And then we can simply adjust the configuration to our needs. Therefore, we can simply move over to the ProxLB configuration file, which is located in etc proxlb proxlb.yaml. And then we can already place the things. We have 4 different chapters. Right now, we have the Proxmox API, we have the Proxmox cluster, we have the balancing chapter, and the service. And the Proxmox API is, of course, the scope of the Proxmox remote API, which we are going to use for orchestrating our Proxmox cluster. And yeah, so as said, and as we already created, we simply add here the information of our newly created user, which is ProxLB at PVE. We do not want to use password authentication, so we can simply remove the things. We created the token ID as ProxLB, and we simply add our new created token. And because we are not using official certificates for the web interface or for the API, we set this to false because we don't want to verify the SSL certificate. And what you're seeing here is that we have the possibility to add 1 or more nodes. And it doesn't matter if it is IPv4 or IPv6. And you can simply define anything, host names, FQDN, it doesn't matter. But ProxLB already also comes with some kind of load balancing for the remote Proxmox API, which means that we can simply add 1 node or multiple ones. And just in case one of the nodes is not reachable because maybe it was faulty, it's offline, or it has a maintenance, it simply takes another node of it. So you can simply use localhost here, you can use any host, you can use many hosts. You can also use dedicated load balancers. Some of you guys also use Nginx or other dedicated external load balancers to load balance the API requests. At this point, we can simply define localhost and we are good to go. And for this chapter, we have more or less everything in place. So the Proxmox API has been configured. And for the Proxmox cluster, we have the possibility to define, for example, maintenance nodes. This is pretty interesting if you're going to have a node which is being security updated or has faulty hardware and needs to be shut down or rebooted. And here we can simply add this node name to the maintenance nodes. It can be one or multiple ones, and the nodes will be drained. This means that all running VM objects will be moved to other nodes just by evaluating all the resource consumptions of the overall cluster nodes. So no nodes will be over-provisioned or something like this. This makes it pretty cool because you can easily move your VM workloads to other nodes in the cluster. But in some cases, you also have the request that you need to ignore a node because it has maybe some special limitations. It has maybe attached some very important PCI pass-throughs for the GPUs or similar things. So you might also add a node name here to make sure that this is being fully and completely ignored from rebalancing actions. And yeah, you can also define if nodes should be over-provisioned or not. So for CPU usage, it might make sense, but for memory, it's not really recommended. So it depends more or less on the method you're going to use the balancing algorithm. So it's up to you what you want to configure there. And afterwards, we of course have the most important chapter. It's about balancing. In general, you can enable or disable the balancing. So this might be interesting if you're going to use the CLI mode, where you're just getting and obtaining the best node for a new placement. This might be interesting when you're using a full CI/CD pipeline and just want to know which node is the most suitable one for placing a new VM object. We can say if we want to enforce affinity groups, because what should happen if we do not have enough resources in the cluster left to enforce or to make the affinity happen, then you can decide, my affinity routes are more important to be ensured than over-provisioning. With this rule, you can simply ensure which is more common for you. We can also define if we want to run migrations of VM objects in parallel. By default, it's just being run in sequential mode, which means that one VM is being migrated after the next one. But of course, we can also define parallel jobs, and we can define the amount of parallel jobs. By default, 5 VMs will be migrated at the same time. But this highly depends on your personal cluster size and how it's being built, because if you're going to use only local storage, all the local storage of even sized VM objects must be migrated. And this might make much I/O on your disk subsystem, but also on the networking traffic. So if you're going to use local disk, you might want to limit this. If you're using Ceph or any other shared storage, you might ramp up the parallel jobs, but it highly depends. Also on your network connection, because of course, everything must be migrated through the network to other nodes. And keep in mind when you're running live migrations, also the disk, or if you have local disk, the local disk will be migrated, the contract state and the memory. So it's a little bit of trade-off, and you need to evaluate which fits best for you. But we also have sometimes some very low-performing cluster systems. So sometimes, in rare cases, it might make sense to disable live migrations. So VM will be completely fully shut down and afterwards migrated, and it will be started again. If we are going to use live migrations, we can also say if we want to include local disk, makes mostly sense, but there are also some corner cases, and you can also migrate the contract state. By default, both are true because it's the most reasonable here. For the balancing types, we have the possibility to balance VM objects, typical VM, virtual machines, or CTs, the LXC-based containers. So it's defined as a list. You can, in this case, define both ones. You can also simply just only migrate the VM objects. We can also do the same only for CT, but by default, we have VM and CT. And if you're going to use local disks, jobs for migrations can take a huge long time, which means we maybe do not want really to wait until infinity, until it's really migrated. So we can define how many seconds it should be waited until a VM job is assumed as being done. So it will simply step over to the next job afterwards. And balanciness. Balanciness is also a very important part because this is the threshold where we are going to migrate or to perform the action. And right now we can see we have a node with just 35, second one with 51, and the first node with 84% of memory usage. And this means we have a huge delta between the third and the first node. And also, depending on how much memory you have overall in your cluster and on the nodes, and if they're in way, it depends on how you want to define the balanciness and how often and frequently it should happen in the end. This means that if we have here, for example, 50 and 51, the balanciness wouldn't happen because the threshold between 50 and 51 is just 1. So it would only happen if 50 and 34, for example, or more than 5. So that would start at 45 already. That would be a threshold that would be reasonable here in the cluster. However, we can also define the method how it should be balanced. So default behavior is here that it's going to be used by memory, but you can also switch over to CPU usage or by local disk usage. And of course, we have a mode which we can define, which is being selected by used mode or by assigned mode, which means when we are using the used mode and the VM has 8 GB of memory assigned, but only used 4 GB of it, it will only make the calculations by the used memory, which is 4 GB, also of course with all other VM objects. If you're going to use the assigned ones, we can ensure that we can guarantee the given resources, for example, to an end customer, that is guaranteed to be accessible. And then it will also just evaluate everything by the assigned memory, which would be in that case 8 GB. The last chapter, we have some things about running the service. So it means if you want to run a daemon service and how frequently the rebalancing action should take place. Here in that case, it's 12 hours. We can also switch it to minutes or any other things. And we can also adjust the log file. And for demonstration, we will switch over to the debug log file, so we can see some more information when we are going to use it. And we are switching back to the use mode. So right now we have configured our Proxmox API. We have the user, we have the token authentication, we have disabled the SSL verification, and we are good to go. So in maintenance is the VIRT66, but you can see there's no node present like this. We can keep it as it is or simply remove it. It doesn't matter at all. In that case, it doesn't matter. Just leave it. And yeah, we are now, I think, good to go to start, to give it a try. And we can see 3 guest objects are already running on the first node, and it doesn't really make sense. So we have 2 other nodes left, but no VM is running there. And let's see what will happen when we're going to start ProxLB. And therefore, we are now starting ProxLB. Let's see the general control what is going to happen. We can already see on the left side, VM migrations are going to happen. And you can see the job is already being processed here. We got a job ID which is being evaluated. While the things are running, and we can see that the VM objects are being shifted right now, which is pretty fine here. We can see that ProxLB exactly does what we expected to happen. And at this case, yeah, we just shifted the VMs. We have 3 nodes, we have 3 guest objects, and each node has 1 VM running right now. So while this already works, we maybe also want to see how draining a node works. Therefore, we manually just shift everything to the third node. And in the meantime, we can already configure the maintenance node for the third node, where we have all VMs running right now. So we are now saying we have dev Proxmox 03 maintenance node. We're just giving a second until all VM objects are being shifted to the third node. All right, so in that case, this might be a typical behavior where we are going to install security updates. So just let's have a quick look. Do we have any packages here? Hopefully, maybe not. Let's see. Taking the packages. So we can't really see the performance is not that good here in my massive virtualization environment. I just forgot to add the Proxmox repository. So let's simply have a look if we have new packages. And indeed, we have some new packages, so we can now simply upgrade the packages. So these packages do not require a new reboot, but let's assume they would require a new reboot, or hey, we have a new manifest, so it might be good to reboot. So no, we don't have. Of course, this is also something we can fully automate. So I already created a patch for Proxmox for the PVE manager, which makes it possible to add a new API path for upgrading a system, where systems can simply being upgraded in an unattended way by the API call. However, we just did it manually here, and the system has been upgraded. The system is up to date, and let's assume we are required to have a reboot here at this time. So we restart ProxLB to take action for the node we set maintenance before. And ProxLB is going to run right now. And you can see it already is creating some migration jobs at all. And it should drain the node right now by shifting all VM workloads to other nodes in a best way of resource consumption. And we can see VMs are being migrated. And in the end, we should end up with an empty node. Keep in mind, this is a nested virtualized environment, so the performance is not good at all. It's more or less only used for development things. So in your environment, it might be much faster. All right, and in that case, the node has been drained. More or less exactly what we expected here. It might be a little bit confusing because we see that three guests are running on the second node here, but this might be because of the memory consumption in general, because it was also heavily used before. This is because there are also still some development things are working in the background, which might influence resource consumption in general, but in the end, our third node is now empty, and we can simply perform a reboot here. All right, now let's move over to the next part. Let us simply create some affinity and anti-affinity. Therefore, let's have some more guests. Simply clone another one. Let's give it a time. Just give it a second. And then and let us simply create another one. So we are cloning an additional one. Perfect. We now have 5 guests in our clusters. Let's spin them up. So we have them up and running. So we can already start. And in the meantime, we can have a look how to configure affinity and anti-affinity roles. And therefore, we have a whole dedicated chapter in the documentation how to do this. And we can already see or it's being achieved here in that way. So therefore, we just create a tag within the Proxmox web interface assigned to the VM object. And to create an affinity rule, we simply define it as PLB underscore affinity underscore and the tag name. So looks pretty easy. And the same applies also to the anti-affinity. So we simply create PLB underscore anti underscore affinity underscore and the name of the group. Let's give it a try. So we're going to switch back to our Proxmox cluster and define some tags. So we're defining here PLB affinity test. All right, we've now created an affinity group with the name test. And let's assign this also to another guest to make sure they are being migrated together to another node. All right, so guest 1 and guest 5 should always be run together on the same node. Now let's create an anti-affinity rule. So therefore we create PLB underscore anti underscore affinity group 2. And we also define it to another node. So no guest 2 and guest 3 should never run together on the same node. All right, what should happen right now? So 1 and 5 should be operated in an affinity group together, while guest 2 and guest 3 should never run on the same node. Let's see if it works. Therefore, we are simply going to restart ProxLB, so it can simply regather all the metrics. And we already see there's a migration job incoming. All right, looks like it finished. Yes, the next run is in 12 hours. So we definitely got what we wanted to have. So we can see we have the affinity groups grouped together on the same node, while we have kept guest 3 and guest 2 apart from each other running on different nodes. So what might be a little bit confusing here right now is that we have also this guest, the fourth guest, running on the second node, because we would probably assume that it is running on Proxmox 3 node, but that's probably because of the wonky setup here, because this is a dev lab and we have different usage here. So we can already see we have 56% of memory usage, even no guest is running here. So this also plays in with the calculations here. However, it is what it is in that case, and we achieved what we wanted to have, and we are good to go. So the next step is we can also simply pin specific guests to a node. So we can now simply remove or modify something here. Maybe we just keep it as it is and now tell that it should pin this guest to the third node. Therefore, we say PLB pin the Proxmox 03. And there's a typo. So PLB pin, let's apply it. So the assumption is that the fourth guest will be operated to the third node. And no, let's simply see if this happens. All right, all migrations have finished, so we don't see any migrations ongoing anymore, and let's see what we got. So we see our guest 4 has a tag PLB pin dev Proxmox 03, which is exactly running on the node we expected and pinned it to. So that's pretty good. So far, so good. Let's see what other ones do. You can see Proxmox, the second Proxmox node, we have the guest running here. We have an anti-affinity group with a guest on the another node. which is running and operated on the first Proxmox node. And this is exactly what we have expected. So those both VMs are running on different hypervisors. Pretty good. And of course, we have our Affinity group. So guest 1 and 5 are being kept together and being operated on the same Proxmox node. And this is how ProxLB operates in Proxmox cluster systems. And within this technical demonstration, we have seen how the general workload distribution works, how the maintenance mode works, how affinity and anti-affinity rules play together, and how we can assign them within the default Proxmox web interface without using or invoking the CLI, and how we can window guests to nodes. And if you have any further questions, you can always reach out at GitHub or in the Matrix and Discord channel. And if you still have some further questions about integrations or even about other things, feel free to reach out to me.